Hi, today we're going to go over the binary number system for computer science. Before we can dive into the binary number system, I would like us to review the decimal number system and understand how it works completely. I think we often take it for granted and lose sight of things. So the decimal number system is a base 10 number system, and we have 10 different symbols for our numbers. And after we get to our 10th number, we run out of symbols. And so what we do is we reset our counting system. So 9 plus 1, we reset back to 0 and carry 1 and put a 1, 0. And then when we get to like 99, we add 1, we get a 0, we carry a 1, we get a 0, we carry a 1, and go to another digit. We definitely take this for granted, but you have to realize that when we run out of numbers, we just go to the next decimal place. Now, the number 4732, that actually has a meaning, and that means that we've got, this is the ones digit, this is the tens digit, this is the hundreds digit, and this is the thousands digit. So we actually have 4 1000s, we have 7 100s, we have 3 10s, and we have 2 1s. And we just add them up, so we basically have 4, that means 4,000, that means 700, that means 30, and that means 2. And when we add them up, we get 4,732. Something to pay very much attention to is 1 is 10 to the 0 power. 10 is 10 to the first power. 100 is 10 squared. 1,000 is 10 to the third. And again, this is called base 10 because each decimal place is multiplied by a factor of 10 as we get bigger and bigger numbers. So now we're going to look at the computer number system, which is base 2, and you can watch the video to understand why it's base 2. But the binary number system just has 2 digits. And just like the decimal number system, we do kind of groups of 3. In the binary number system, and we call each one of these a bit. It's a bit of data. You can see the origin again in another video. And so when we write down our numbers, especially in computer science principles, we will group them in blocks of 8. 8 bits we call 1 byte. There's not a lot of vocabulary that I'm going to be throwing at you, but this is vocabulary that's important. So remember, a bit of data is just a 1 or a 0. 8 bits is equal to 1 byte. So very often we group 8 bits together and we put a little gap between 4 and 4. And it's just for readability. It's the only reason that we do it. But that you're going to see numbers like that. So when we add 1 to this number, we get 0, 0, 0, 0, 0, 0, 0, 1. When we add 1 to this, 1 plus 1 has to reset when we carry 1. So 0, all zeros is 0, plus 1 is 1, plus 1 is 2. And this is what our binary system is based off of, and we're going to keep exploring this as this lesson goes on. So what we're going to do now, and I'm just going to write out half of a byte. I'll just do 4 zeros. 4 zeros is equal to 0. Adding 1 to 4 zeros, you get 0, 0, 0, 1. That's equal to decimal 1. Now when we add 1 to that, 1 plus 1 is 0. Carry the 1. It's 1, 0, and that's 2. When we add 1 to that, we're going to get 0, 0, 1, 1. And that's going to equal 3. And when we add 1 to that, 1, 1 plus 1, we get 0, carry the 1, 0, carry the 1, we get 1, 0, 0. So we get 0, 1, 0, 0, and that's 4. And then we get 0, 1, 0, 1, and that's 5. And then from 101 plus 1, we will get 0, carry the 1, bring down the 1, and that's 6. So 0, 1, 1, 0 is our value 6. 7, 8. Now I'll keep counting up. Space here. A little more space. And so that's 9, 10, 11, 12, 13, 14, and 15. And then we'd have to add another bit to get to 16. Adding two numbers. It's the same thing as adding in decimal. You get 1 plus 0 is 1. 1 plus 0 is 1. 1 plus 1 is 0. Carry the 1 is a 1. And that's just how you add two numbers. Now let's convert a decimal to binary. To convert numbers, we have to remember that our binary digits have values, have place values. And I like to write out 8 zeros, and then what I will do under those 8 zeros, if I'm converting, I will write the number 1, 2, 4, 8, 16, 32, 64, and 128. And this is 2 to the 0, 2 to the first, 2 squared, 2 to the third, 2 to the fourth, 2 to the fifth, 2 to the sixth, and 2 to the seventh. 2 to the 7th is 128. Just like, go back to our base 10 is 10 to the 0, 10 to the first, 10 to the second, 10 to the third. We're doing the same exact thing, except that we're doing it with 2s. It feels a little less natural because you're not as used to it, but it's the same, same logic. So if I have the number 37, all I have to do is figure out, okay, which bits have to be turned on to add to be 37. So there are no 128s. There are no 64s. But we can turn on a 32. And 32, there would be five more values that we have to get together to get to 37. So we have 32 plus 5. There's no 16s. There's no 8s. And you can probably see 4 plus 1 is 5. So 32 plus 4 plus 1 equals 37. And that's how you can convert from decimal to binary. I'll do one more. So let's do 67. So we have no 128s. We do have a 64. And 64 minus 67 is 3. And so then we just have to do 3 more. We have none of that, and we've got those two. So and this equaled 37. Decimal binary. To convert from binary to decimal, again, I use the same trick at the top. 1, 2, 4, 8, 16, 32, 64, 128. And so if I have the number 0, 1, 1, 1, 0, 0, 1, 0, all you have to do is you have to see which bits are turned on, and you've got a 64-bit, an 8, a 4, and a 2. And all you have to do is add them up. So 78. So the number 0, 1, 0, 0, 1, 1, 1, 0 is equal to 78. If we just go back real quick before we leave. When we were adding, we got 1, 1. I'm just going to look at this number right here just to make sure that everything lines up, which it will. But to convert 1, 1, 1, 0 to decimal, so we have 1, 1, 1, 0. And so what we do is we add 8 plus 4 plus 2, which is 14. So we can just see that that, in fact, was consistent. I think I did one other thing that I'd like to look at. I'd like to figure out what numbers did we add up here to make sure that we're consistent. So again, so we got 0, 1, 1, 0, and so that 4 plus 2 is 6. So this is equal to 6 over here. We've got 0, 1, 0, 1. 4 plus 1 is 5. We know that 6 plus 5 is 11. So that last number better be 11. Let's just check. 1, 0, 1, 1. This is 8, 2, and 1. 8 plus 2 plus 1 is 11. So the math works, and it is consistent. And that's our quick lesson on binary today. Thank you.